So this will be the solution for quiz 1. I'm gonna, record a video where I walk through, my process for doing this, and also I'll, upload this as just a PDF. That way, people who don't want to hear me talk don't have to. The first question for quiz 1 was to find this area. So it's the area enclosed by y is equal to the square root of x minus 1 and x minus y is equal to 1. We want to graph these things. So the first thing I'm going to do is I'm going to solve these both for y, and the first one's already solved for y. So we get y is equal to the square root of x minus 1, and y is equal to x minus 1. So when we graph those, square root of x minus 1 is the square root function shifted 1 to the right. So it's going to look something like that. And then x minus 1 is the line y equals x shifted 1 to the right. Or you just plot 2 points and draw the line, and it's not really big there, but that's the area that we're looking for. And so for this one you can use, for the area, you can do, top minus bottom or right minus left, doesn't matter. I think the right minus left is easier, but most people did it as top minus bottom. So I'll do it that way. So we need to figure out, so our area then is going to be the integral from a to b, top minus bottom. And then we're going along the x direction here, so it's going to be dx. And so we need to figure out our bounds. Well, the first, we can see what a is already. A is going to be 1 just from the graph. And then to figure out what b is, we're just going to solve the equation x minus 1 is equal to the square root of x minus 1. Because we already know that x equals 1 is a solution, I'm going to divide both sides by the square root of x minus 1. It's maybe in a different color for people who are just looking at this. So I'm going to divide by square root of x minus 1. And again, I have to make sure that, when I do that, I already know that, okay, I know x equals 1 is a solution. So then I have square root of x minus 1 is equal to 1 if I square both sides. So again, maybe do that in blue for the people just looking at the note. So square both sides to get rid of the square root. We're going to get x minus 1 is equal to 1, or x is equal to 2. That gives us what b is. That tells us b is equal to 2. Now if we look back at our picture here, top function is the square root of x minus 1. Bottom function is x minus 1. So our integral then is going to be the integral from 1 to 2. Top function was square root of x minus 1. Bottom function was x minus 1 dx. That's going to be our area, and now we just have to solve this integral. This one you do by breaking it up into 2 integrals. 1 to 2 square root of x minus 1 dx minus the integral 1 to 2 x minus 1 dx. First one, you can do a u substitution if you need it, but this is going to be x minus 1 to the 3 halves divided by 2/3. Sorry, divided by 3 halves there. When you flip it up, it becomes 2/3. I don't usually do this step. I'll just write out the thing or the coefficient in front of it. And then minus, and then we're going to have x squared over 2 minus x. And both of these are evaluated from 1 to 2. So when I do this, I'm going to get 2 minus 1 to the 3 halves times 2/3, or divided by 3 halves. Minus what I get when I plug in 1. When I plug in 1, I get 0. And then I'm going to subtract. I'm going to plug in 2. So I'm going to get 4 over 2 minus 2. And then subtract off what I get when I plug in 1. 1 over 2 minus 1. So this ends up being 2/3 minus, so we have 2 minus 2 minus 1/2 plus 1. Is that right? Yeah, seems like it. So then this is 2/3. You end up getting a minus 1/2 there. and then this ends up being 1/6. You want a positive number. If you get a negative number, it's because you flipped the order. You did bottom minus top or something similar. So yeah, so that was the first one. I don't remember what the second one was. I'm pulling it up. So the second one, we just had to set up, yeah. So this one was just set up the integral to find the volume obtained by rotating y is equal to 10 minus x squared and y is equal to 7 about the y-axis. And so when you do this, so when you draw this, 10 minus x squared is the graph of negative x squared, shifted up 10. Line y equals 7 is a horizontal line that goes through y equals 7. And now, so what we're doing is we're taking this area and we're rotating it about the y-axis. So we're, rotating it in this direction. So we're going to get a solid that sits up there. So if you look at, one of the big mistakes people did is they tried to do, cross sections in the direction that I just drew in red. And that's not what you want to do here. So the idea behind this is, we want to pick cross sections, and there are two different cross sections I can do. I can do the one in red, or I can do the one in green there. So if you do the one in red, that's not going to be any kind of shape. So when you look at that cross section, that's actually going to be, looks like a cylindrical shell. So I guess maybe you could do it that way, but you have to be careful. So we're not going to do with the red one, we're going to do with the green one. Green one is discs. Discs are easier than cylindrical shells. So you get area then is equal to pi r squared, where r is the radius of the disc. If you look at the disc, any of these discs, let me get rid of the two colors here. Let me get rid of all those colors. That's not what I wanted to do. Okay, whatever. So if you look at all these, if you look at these discs here, so the radius of any of these discs, if I have this point x, y here, the radius of that disc is going to be whatever that point x is. So then this area then is pi times the radius squared, while radius we just said is the x coordinate. So it's going to be pi x squared. So what we're going to do is we want to figure out, if I think about, what direction am I, what is going to be my integration variable, you should notice that when I, make these discs, when I give them a little volume, it extends in the y direction. So because it extends in the y direction, I'm going to integrate dy. So that tells me then that volume then is the integral area dy. So if I plug in, I'm going to have pi x squared dy, but this doesn't work. I can't have x squared in my integral and also have a dy there. That's because it's telling me to integrate with respect to y. So I need to solve for x. So solve y is equal to 10 minus x squared for x squared. When I do that, I'm going to find x squared is equal to 10 minus y. So my volume then is going to be the integral pi times 10 minus y. And I also need to put bounds on here, so I should have been putting a to b on all of these. So if I go up and try and figure out what my bounds are, they're actually pretty clear here. So just from how I've drawn the plot here and all the things I've used, or all the things I know about parabolas, so it starts at y equals 7, ends at y equals 10, and that's going to be that. And you didn't have to evaluate this. This was the final answer. And so be careful on that when, when I write these questions, I'm not always going to ask you to evaluate, just because, I want to save you guys time. I don't want these to take forever. So just watch that, and then also just be cognizant of, what kind of shape you're going to use. A lot of people tried doing these vertical cross sections and then would use the formula for discs or washers or something. So you have to be careful about, what shape am I getting when I look at these cross sections.